This is Senior Algebra section 3.5, solving inequalities by graphing. So today, when we graph a linear inequality, we're going to graph two things. We're going to look at the boundary line and the shading here. So step one, looking at the boundary line. So we're going to graph the line. It's just like we graph any other line. The only difference is this. When I have greater than or less than, I'm going to have a dashed line. Now remember, the line means that at that point the things are equal. The left side is equal to the right side. So I want it greater than or equal to. I'm going to use a dashed line to say that's not equal to. Now, when I have a equal to or not equal to, or equal to or greater than or equal to or less than or equal to, I'm going to use a solid line because that is part of the solution. Second part is shading. So the rule is this: I can use any point that's not on the line. Now, the easiest point to use is 0, 0. Okay, and I test that point. Remember, 0, 0 is also known as the origin. So I'm going to test that point, and if it's true, that's where I shade. That's where the answers are true. Every point there is true. If it's false, and then I would shade the other region. Now I could also test another point, but it's not really needed at that. So taking a look at example 1 here. I'm going to graph this inequality. I'm just going to graph the line, -5. So I'm going to start a y-intercept up 2 over 3. It's less than, so I'm going to use a dashed line to show that I cannot use the points on the line, because the points on the line are equal to. So now I have to figure out, where do I want to shade? Do I want to shade above or below here? So I test a point. The easiest point to test is 0, 0, because 0 times anything is 0. Everything falls out. Makes it easy. Again, you could test 5, -7, but why? Why make it harder on yourself? So if I test 0, 0, I get 0 is less than -5. Is that true? 0 is less than -5. Nope, that is not true. So everything in that region is not shaded. That's false. So where would I shade? I would shade in the other region. Now, I can also test a point in that region just to show you. So if I tested any point in that region, okay, I picked 2 there. I'm just going to pick one of them. I'm going to go with 6 and 4. If I put in 6 and 4, I get this. I get -4 is less than 4 minus 5, or -4 is less than -1. Is that true? Yes. So that's why I shaded in that region, because it's true. Now again, I don't need to test the other point, but I could. In example 2, again, I'm going to graph it. Move the 5 over. Now when I graph it, I'm going to get x is greater than or equal to 3. That's a vertical line, and it's greater than or equal to, so I'm going to use a solid line. At this point, I test. And again, I'm going to put in 0, 0. Now, there is no y, but that doesn't matter. I get 0 is greater than or equal to 3. Is that true? No, that's not true, so I would shade in the other spot. And if I think about it, what numbers are greater than 3? Oh, 4, 5, 6. So I would shade that way to the right. Last one, I'm going to subtract 5x. I'm going to divide by a -2, and I get y is 5 halves x over there. But I divided by a negative, so I have to remember to flip the inequality. Now this is a little bit tricky, because what's the y-intercept? In this one, the y-intercept is 0. So I'm going to use my slope. I'm going to go up 5 over 2, up 5 over 2, up 5 over 2. I'm going to use the dashed line because I don't want it equal to. Now when I put in 0, 0, the problem is this. I get 0 is less than 0. It's right on it. Okay? So I have to pick another point. Okay, I can't pick 0, 0. So I can pick any point I want. I'm going to pick an easy point. I'm going to pick 4, 0. X is 4, y is 0. I'm going to plug it in and see, do the same thing. Is it true? If it's true, I would shade that in that region. If it's false, I'm going to shade in the other region. So when I plug in 4, I get 20 is greater than 0. Is that true? Yes. Since it's true, that's where I'm going to shade. Eventually. There it is. So I'm going to shade in that region. Again, I could have tested any point in that region and it would have been true.